Hello, and welcome to The Explainer. As someone who's spent years in the trenches of industrial cybersecurity, I want to talk about something absolutely fundamental today, the IEC 62443 standard. We're going to unpack what it is, why it's so important, and really why you can't afford to ignore it if you're in the OT space.
So let's get right to it. Why does this matter so much? Because in the world of industrial systems, the stakes couldn't be higher. We're not just talking about leaked emails or stolen credit card numbers. A cyber attack here in an OT environment can shut down a factory, contaminate a water supply, or worse, it can have real physical consequences. And this isn't just some what-if scenario. We've seen it happen. Remember Stuxnet? That wasn't just code. It physically destroyed nuclear centrifuges. Or the blackouts in Ukraine? Cyber attacks literally turned the lights off for hundreds of thousands of people. And then there was Triton, a piece of malware designed to attack the very systems meant to keep industrial plants from exploding. This is the reality we're dealing with. Okay, so how do we fight back against these kinds of threats? Well, the international community got together and created a game plan, a specialized framework just for this problem, and that's IEC 62443. Think of it as the security playbook for the entire world of industrial control systems. So, here's our roadmap for today. We'll kick things off with the threat landscape, then get into why OT security is its own special beast. From there, we'll pull apart the IEC 62443 standard, talk about its core ideas, see where it's used, and finally point you in the right direction to get started. Right? First up, understanding the threat. And the key thing to remember here is that digital risks have very real physical consequences. Think about it. When someone hacks the systems running our power grids or water plants or our factories, the fallout is instant. The lights go out, production grinds to a halt. This isn't about protecting servers in a data center. It's about protecting the physical infrastructure that our entire society depends on. One vulnerability can cause a ripple effect that touches everyone. And that brings me to a really crucial point. You can't just take your IT security team, drop them in a factory, and say, go secure this. It just doesn't work. OT and IT are two completely different worlds. So when we say OT, or operational technology, what are we actually talking about? Well, it's all the tech that makes things happen in the real world. It's the controllers on a robotic arm, the sensors in a chemical vat, the SCADA systems that manage the entire electrical grid. You know, the stuff that actually keeps the lights on and the assembly lines moving. And here's where things get really different from IT. Look at the priorities. In the IT world, it's all about confidentiality first, protecting the data. But in the OT world, it's flipped on its head. The number one priority is availability. You can't just take a power plant offline for a patch Tuesday. It has to run 24/7. So keeping things available and ensuring the integrity of the process, all while maintaining safety, that's the whole game. And the challenges here are just unique. You're dealing with equipment that might be older than some of the people operating it. We're talking 20, 30 years old. These systems were built for reliability, not for a world with internet-connected threats. Trying to patch something can feel like performing open-heart surgery, because if you mess it up, the whole operation goes down. So often, you just don't. So, given all these challenges, how does IEC 62443 actually help? Well, its genius is that it creates a framework for everyone involved. It understands that security isn't just one person's job, it's a team sport. And this really gets to the heart of the standard. It's all about shared responsibility. You've got the asset owner, the company running the plant. You've got the service providers who install and maintain the systems. And you've got the product suppliers who actually make the devices. IEC 6243 gives each of them a clear role to play in the security chain. No one gets to pass the buck. The standard itself is broken down into 4 big pieces. Part 1 is kind of the foundation. It sets out all the basic concepts and terms, so we're all speaking the same language. Part 2 is for the asset owners. It's about how you manage security as an organization. Part 3 is for the system integrators, how you build a secure system. And Part 4 gets right down to the nitty-gritty, the security requirements for the actual devices themselves. You can see how they all fit together to cover security from top to bottom.
Okay, let's zoom out a bit. Why does this standard matter to, well, everyone? Because it's about protecting the things we all depend on to live our lives. I mean, look at this list. We're talking power grids, water treatment plants, the factories that make everything we use, the trains and buses we ride, even medical devices in the buildings we work in. All of it runs on OT, and all of it is a potential target. And because this stuff is so critical, governments are taking notice.
Following IEC 6443 isn't just a good idea anymore. It's becoming the law in many places. Big regulations like the NIS2 directive in Europe are built around the principles of this standard. So if you want to be compliant, this is your starting point.
All right, let's get into some of the core ideas that make up the standard. These are really the building blocks of a solid defense.
The standard relies on some really solid, time-tested principles. You've got defense in depth, which just means having multiple layers of security. If one layer fails, you've got backups. It's also risk-based, which means you put your biggest fences around your most important assets. And it's not a one-and-done thing. It's about managing security through the entire life of a product, and always, always monitoring what's happening on your network. One of the most powerful concepts in the whole standard is something called zones and conduits. It's basically a smart way to do network segmentation. Imagine your plant is a ship. You don't want one leak to sink the whole thing, right? So you have watertight compartments. That's what zones are. You group similar equipment together into a secure zone. The conduits are the secure doorways between those compartments. If a hacker gets into one zone, they're trapped. They can't just wander around the whole network. Okay, so we've covered a lot of ground. The what and the why. Now let's talk about the how. Where do you even begin with this?
And if there's one thing I want you to take away from this, it's this. IEC 62443 is not a checklist. It's not a list of products you can buy. It's a way of thinking. It's a continuous process for managing risk through the entire life of your systems, from the day they're designed to the day they're retired. Now, obviously, this was a 30,000-foot view. There's a lot more detail to cover. In our next few explainers, we're going to do just that. We'll take a much deeper dive into each of the 4 parts of the standard, so stick around for that. So I'll leave you with a question to chew on. How ready is your own organization to really think about security this way, as a full lifecycle process? Really think about it, because answering that question is the first step toward building true cyber resilience. Thanks for joining us on The Explainer.